let's solve the example 2.5. So determine the x and y components of f1 and f2 in Cartesian vector. So before that, you must remember what is the first step in order to resolve the force into Cartesian vector. So now, so this is 2D cases. So here we have, so this is x direction, this is positive x, and then this is the y direction. So you have two force here. So you have F1. So for F1, so we need to resolve the F1 into Cartesian. Cartesian means that I and J. So look at here. So we need to resolve the F1 into component I and J. So here F1, so we have resolved into Fx. So here we have F1 x, and then here we have F1 y. Okay, so after we resolve into this one, so you need to know this is negative. Okay, must remember that. So now you can write, after you resolve, then you can write. So what is the F1y? So F1y here is given that F1 is 200, the magnitude is 200, and this is the angle. The angle is 30 degree. So you can have that F1y is equal to, so because of this degree is near to this axis, so it can have 200 cos 30 degree. So the unit here is Newton. So you write Newton. And then here your F1x, so we are using this angle. So F1x become 200 sine 30 Newton here. So when you write, you must write the negative here. Don't forget. So here your F1 is equal to negative 200 sine 30. So you solve, it is negative 100 Newton. And then F1, 200 cos 30 is 173. So how to write in Cartesian? So here 1x is referred to I, 1y is referred to J. So you can write F1 is equal to negative 100I plus 173 J Newton. So this is how you write the force into Cartesian. Okay, next, let's write for the F2. So here, this is the F2. So you need to resolve into component. So you have F2x here, and this is F2y. So must remember, this is negative y, and this is positive x. So x means that I, y means that j. So now, the question gives us the scale here. So you know how to do this scale to get the theta? Because we need the value of theta here. So this theta value is equal to this theta, right? So now, if you want to know this theta, so you can have, you can resolve into this theta. So this theta here is equal to this magnitude. Okay, F2x is equal to 260 times 12 over 30. So 12 over 30 is the cos theta. So cos theta in this triangle, this small triangle, is 12 over 13. So that is why here you just write 12 over 13. No need to write cos theta. So because we already resolve. So we are using, let's say here we are using this, this inside angle is 12 over 13. So already represent for this angle. Okay, next we resolve into F2y. So F2y, we need sine theta. So sine theta means that 5 over 13. So that's why you only write 216 times 5 over 30 Newton here. then we get the magnitude. So F2X when you solve is equal to 240. Okay, this 240, and then F2Y when you solve 260 times 5 over 30 is 100 Newton. So must remember F2Y is negative, F2X is positive. So this is how you write the F2 in Cartesian vector, 240I minus 100 J Newton. Next example 2.6. So here determine the magnitude and direction of the resultant fall. So for resultant here and angle here. Okay, so this is also 2D. So now you have how many forces? So you have F1, you have F2 and F3. So the question gives us only magnitude. So first step here, you need to resolve into component X and Y. Means that you need to resolve into Cartesian I and J. Okay, second step, after you resolve into I and J, then you need to add the respective components to get the first resultant. Because you must remember that FR is equal to FRXI plus FRYJ. And then the third one, after you determine this vector first resultant, then you can calculate the magnitude and also the direction. Next, let's do the first step. So resolve the force into component X and Y. So now refer to this F1. So this is the F1. So this F1, we need to resolve into the component Y. This is positive Y and this is the X positive. So this is the negative X. Okay, so now F1. So F1 magnitude is 300 Newton. So we need to resolve into I and J. So this is R and this is J. So do we have here in X? Because the F1 is already in Y. So in X, we have 0. Because if we resolve into this is sin 90, is also 0. Right. So we need, so this F1 is already in Y. So we just write 300J. So all component is in positive. So here you can have that 300J. So next is F2. So this is F2. So this F2 is resolved into this X, Fy, and then F2. Okay, this is F2F, X, and then is the F2Y. So this is the angle 45 degree. So you can resolve into the F2X and F2Y. So you can write like this. So F2 is equal to negative, because of direction in X is negative. So negative, the magnitude is 450. So negative 450 times cos 45. Because this angle is near to the x-axis. So that is why it becomes cos. So must remember this is component I. And then plus with the F2Y. F2Y is 450 sin 45. Must remember component J. And then the last one, unit Newton. So we can solve the magnitude for the F2X and F2Y. So this is the last Cartesian for the F2. So F2 here is negative 318.2 I plus 390.2 J Newton. Okay, the last one for the F3. So this is the F3. So F3 here, you resolve into F3x, and then this is the okay, F3y. Now, what is the component of 3x and F3y? So here, you are given by this scale. So you have this 3, 4, and 5. So we need this angle theta. So this angle theta is similar to this theta, like this small. So this is small theta is similar to this theta. So now, so you have here F3x. Okay, F3 is equal to, so now we want what is the cos here. So cos is equal to 3 over 5. So you just write 600. So the magnitude is 600. So 600 multiply 3 over 5i plus F3y is equal to 600. Okay, 600 sine 4 over 5. So you can solve, and then you can write F3 in Cartesian is 360i plus 480j. Okay, you got it? Okay, the last step, okay, second step, we need to sum all the respective component into I and J, because we understood that Fr is equal to F1 plus F2. Okay, so here we already group into the I component and J component. Then you can solve, and this is the vector for the force resultant. So we have here 41.8i plus 1098j. So this is the vector for the force resultant. Now we want to determine the magnitude. So the magnitude, so you can have like this. Okay, so this is the 41.8 exponential 2 plus 1008 exponential 2. You can get the resultant force magnitude is 1099 Newton, and the angle, the direction angle is FRY divided by FRX here. So angle is 87.8 degrees. So this is the angle counterclockwise from this axis. Okay, you got it? Next is example 2.7. As usual, determine the magnitude and directions of the resultant force. So the question asks us to determine the resultant force and the angle. Okay, so now, is it our force is already in Cartesian? Yes or no? That is the first question you should ask yourself. So now, how many force you have? 3, right? So we have F1 magnitude is 850 Newton, F2 625 Newton, and then we have F3 750 Newton. So now we need to get the FR. So we understood that FR is equal to F1 plus F2 plus F3. So what is the first step? So first step is resolve K into I and J. Okay, second step. Okay, adding. So you need to adding and in respective I and J. And then the third step, you can solve the magnitude of the force resultant and direction angle. So now step 1, resolve into I and J. So now we have F1. So F1 here, you resolve into X and Y. So you have F1X and F1Y. Can you do that? Okay. And then F2. So F2 you have F2x here, and then here you have F2y, and then the last one F3. So F3 here, okay, F3 here, this is you have, okay, F3x and also F3y. So don't forget the positive x, positive y, negative x and negative y. Right, and then don't forget also this is given the angle 45 degree, and this is 30 degree, and then this is scale. So this scale, so this angle is equal to this angle. So you must know how to use this scale given. You got it? Then you can write the forces. So this one, F1 you can write here, you have 850. So this one, because of this, okay, because of this cos theta. So this cos theta is equal to 4/5. And then, okay, we need to, this one. So this is F1x and this is F1y. Okay, so you have F1x here, and then this is F1y. So this is the answer here. So this is sine and this is cos. Okay. Okay, next this is F2. So this is F2. That's what we have. So this is the F2x and this is the F2y. So here we have negative. So negative 625 sine 30, and also F2y is also negative 625 cos 30 J here. So this is the answer. So you can write F2 is equal to 312.5 I minus 541.3 J Newton. Okay, and the last one is for F3. So here is your F3y and this is your F3x. So F3x is negative. So you must write negative 750 sine 45 I plus 750 cos 45 J Newton. So you can write, okay, F3 is equal to negative 430.3 I plus 430.3 J. So what is the next step? So next step, we need to group all the forces into force resultant. Okay, so this is the last step. So we sum all. Okay, here we summing all the I and J component respectively. So we have group here. This is in I and this is in J. So this is the vector for the resultant force. So you must understand that force resultant is equal to F1 plus F2 plus F3. Okay, so you need to group into I and J. And then for the magnitude of the force resultant and direction angle, so we can use the formula that this is the formula. So this is the FRX expression 2 plus FRY expression 2. So you have the magnitude for the force resultant is 446 Newton, and this is the direction, this is the angle. So the angle is 420.9 divided by 162.8. So this is the 72.6. So if you sketch the force resultant is here. Okay, so this is the negative 120.9 and this is 160. So the quarter is in negative part. So if you want to measure from the positive axis, so our angle is 360 minus 72.6. So if this direction is become 250 degree, because this degree is in this quarter. Because usually we measure from this axis counterpart to the force resultant. Okay, you got it? Next, example 2.8. So determine the force F as Cartesian vector. So this figure show the 3D cases. So because we have axis here x1 and z, so must remember the right-handed. So the right-handed represent that z upward term is equal to positive, and this is positive x, and this is the positive y. So must remember this is I, J and K. So now the question asks us to resolve the force in Cartesian vector. So Cartesian means that you need to resolve into I, J and K. So we have the relationship here. So because the question gives us the alpha, beta and gamma. So now you need to identify what is the value for alpha, what is the value for beta, and what is the value for gamma. So you must remember alpha is measured from where, beta is measured from where, and gamma is measured from where. So this is the force. So here, do we have value for the alpha? Here. No, right? Beta? What is beta? So here beta is equal to 60. Because beta is from the force into the y-axis or j direction. And then gamma. Gamma is from this force into z or k direction. So we have gamma is 45 degree. Now, how to determine the alpha? Because we want to write into Cartesian, so we can use this formula. So we can resolve the force into Cartesian by this relationship, which is F is equal to F cos alpha I plus F cos beta J plus F cos gamma K. So now we already have the value for beta and gamma. So only for the alpha. So now you can use this relationship. Two angles are specified. The third angle is found by this relationship. So you can substitute the beta and gamma. So it's equal to 1. Alpha plus 60 plus 45 is equal to 1. Then you can have that alpha is equal to positive and negative 0.5 here. So you can have the two possibility for the alpha. So alpha is equal to shift cos 0.5, it becomes 60, or you can have alpha is equal to shift cos negative 0.5 is equal to 120. So here, can you guess which value alpha we want to choose? Is it 60 degree or 120? So you need to refer to this axis. Now our alpha is positive or negative? This is I direction. So this alpha. So alpha here is in positive. So if positive, we need to choose alpha is equal to 60. You got it? Okay. So after we obtain the alpha, then you may substitute into the relationship here. So we have f is equal to 200, then you can solve. So 200 cos 60 I plus 200 cos 60 j plus 200 cos 45 k. So don't forget the unit in Newton. So now you can solve, then you can write the force in Cartesian term is equal to F is equal to 100I plus 100J plus 141.4 Newton. So this is how you can resolve the force into Cartesian. So this is you can checking is it the magnitude of the force is similar to what the question has been given. Next example 2.9. Determine the magnitude and coordinate directions of the resultant force acting on the ring. So this one, as usual, we need to determine the resultant force and what is the coordinate direction. Coordinate direction means that you need to determine the alpha, beta and gamma. So now how many force do you have? So you have two, right? So you have F1, you have F2. So your F1 and F2 is already given in Cartesian. So now you need to determine the force resultant and coordinate direction angle. So here you can have the how to determine the angle. So here you can have the bar law here. Okay, you can guess this is the force resultant. So now you know that you understood that alpha is measured from the so we measure the alpha is measured from the force resultant to the x-axis. So this is alpha, and the beta is measured from the force resultant to the y-axis, and then gamma force resultant to the z-axis. So how you can determine the alpha, beta and gamma? So of course you need to sum. You need to add the F1 and F2. So after you add, you need to grouping into the respective component I, J and K. Then you have to determine the magnitude. Okay, let's do that. Alright, so now we need to add all the force here. So force resultant is equal to summation of all forces. So now we have F1 and F2. So now this is the F1 and this is the F2. So we need to group into I, into J and K. So this is the vector for the force resultant. Now from this you can determine the magnitude by using this formula. So you can solve here. So you can determine that the magnitude of force resultant is equal to 191 kilonewton. So because our force here is kilonewton. Next, so we want to determine the coordinate direction angle. So before we determine the coordinate direction angle, okay, so we can use the unit vector here. So we understood that the unit vector is like this. So here we have unit force resultant is equal to cos alpha R plus cos beta J plus cos gamma K. So you can have that the value for this alpha, beta and gamma is become like this. So we need to have the cosines of FRX and FR. So you already have the FR. Okay, so this is our FRX vector and this is FRY and this is the FRZ. So you can substitute into this formula, then you can solve. So you can have the alpha is equal to 74.8 degree, beta is equal to 102 degree, and gamma is equal to 95.5 degree. So here noted that beta is more than 90 degree Okay, because J component of the unit vector is in negative. So that is why you have, okay, we have already sketched, right? So this is alpha from this force and this is beta. So that because of this beta is more than 90 degree. Because the force resultant is in the quarter of negative. Okay, this is our gamma. Okay, this is how we can solve the 3D coordination direction angle. You got it? Next, example 2.10. Determine the magnitude and coordinate direction of the resultant force. So as usual that you need to determine the resultant force and then the coordinate direction angle. So coordinate direction angle for the 3D cases, so you should have the alpha, beta and gamma. Okay, so now how force you have? So you have F1 here and F2. So is it the force is already in Cartesian or not? So if not, so step 1 you need to solve into Cartesian. And then after that, as usual, okay, so you can add to get the force resultant. And then this one you need to resolve into Cartesian, and the third one to determine the alpha, beta and gamma. Okay, take a look here. So this is the F1. So F1 here, so here we have the axis. So okay, so you must remember our right-handed. Okay, so this is the positive z, positive y and positive x. So now for this case, okay, now we want to write the F1 into Cartesian. So now you need F1. So this F1, so you need to resolve into F1 x, so you need to resolve F1 y, and then you need to resolve into F1 z. Okay, so here if you can see that our F1 is here. Okay, so straightly, so here you straightly this angle, okay, you can straightly resolve into F1z, okay, by using this 35-degree angle. But okay, this is negative, but for the 1x and 1y, you need to resolve this F1 into this plane. So this plane you can have F prime. So this F prime you can resolve by this 250, because of this is the plane okay, because this plane is to resolve for y and x here, right? So that's why we need to resolve the F1 into F prime. So F prime here is equal to 250 cos 35 degree. So after you resolve at this F prime, then you can resolve into F1x and F1y. So F1x is here to the axis x. So here you can have that the magnitude of F prime. So here go to the x-axis, you can use this 25 degree. So sine 25. So F1y is F prime cos 25 degree. Okay, so your F1z is 250 sine 35 degree. Okay, so this is for the F1. So how about the F2? So F2 here is very easy because the question gives us the value of angle, but you need to determine. So what is this value? So this 120. So 120 is what? From this F2 into x-axis. So this is alpha. So this one 45 degree. So from the force to the axis y. So it is beta. And then this one 60 from force to the z axis. So this is gamma. Then you can resolve into Cartesian. The F2 is equal to what? So you can have that 400 cos alpha I plus 400 cos beta j plus 400 cos gamma k. Right, so that is the first step. Okay, so this is how the answer for the F1 if you can resolve into Cartesian. Okay, so this is, you should have the answer like this. So this is the answer. So F1 is 86.6I plus 185.6J minus 143.4K. So the unit is Newton. Next, so this is the F2. So F2, so you can write F2 is equal to negative 200I plus 282.8 plus 200K. Then after you write into Cartesian, then you can go to step 2. You add everything and then you group into I, J and K. So this is FR is equal to F1 plus F2. So and then this is the vector for the force resultant. So this is the answer. Then the question asks to get what is the magnitude and coordinate direction angle. So you can solve for the force resultant. So this is square root. So this is the answer. And next you can have what is the alpha, beta and gamma. So this is the answer for alpha, beta and gamma. You just substitute into the equation. You got it? Next example 2.11. So here determine the coordinate direction angle of F2 so that the resultant force FR act along the positive y-axis and has the magnitude of 800 Newton. So for this case also is in a 3D. So now you need to determine what is the F2 coordinate direction angle. So F2 is given the magnitude is 700. Then you need to find what is the alpha, beta and gamma for the F2. So your FR, so your FR is 800. So your 800, so acting in the y-axis, so positive y. So positive y means that 800 J. Right, y is J. Okay, so now what you should do. So here we have F1. So magnitude F1 is 300 and then F1 is already given the alpha, beta and gamma. Then you need to identify what is the value of alpha, what is the value of beta and gamma for the F1. So must remember, so here the question asks to get what is the alpha, beta, gamma for the F2. So you need to resolve the F2 into Cartesian, right? Okay, so here you must remember the first step. Okay, the first step is to resolve into Cartesian. So you need to resolve F1 into Cartesian. So you can have that 300. So what is the value here? So F1, okay, from F1 to this one is alpha. And this force to this is the beta. And this one, this is the gamma. Alright, so you have here 300 cos 45i plus 300 cos 60k plus 300 cos 120k. So that is the for F1. So now F2. So F2 you have the magnitude is 700. So you have to determine what is the alpha, beta and gamma. So now the component F2, you can have you can make it as like this. F2xi plus F2yj plus F2z. F2 F2zk. F2zk. Zk. Like that. Okay. And then step 2. Step 2, false resultant is equal to F1 plus F2. So FR you already know that 800G. So here you can group everything into I plus J plus K. Then you can equate with this. Okay, after you equate with it, then you can solve what is the F2. Can you do that? Okay, so here for step 1. So this is for step 1. So step 1 here. So you need to write what is the F1. So now this is the answer, F1. And as usual, this is the F2. We just represent F2 into the F2xi plus F2yj plus F2zk. Alright, so next. So now we can have, okay, because we understood that Fr is 800 Newton and act in the J direction, positive J direction. Okay, so you can equate here. So after you grouping into component I, component J and component K, so you can equate that because here first resultant we have only 800J. So that means that our first resultant is equal to 0I plus 800J plus 0Z. Right? Okay, so you can equate. So this one is equal to 0, J is equal to 800, and this one also 0. So you can solve here, you can equate this 212.1 plus F2x. So you can have it equate to 0, then you can get F2x is equal to negative 200 F2.1 Newton. And then this group J, you equate with the 800. So you can determine F2y is equal to 650 Newton. And the last one here, Z. So you can have that 0 is equal to negative 50 plus F2Z. So you can determine that F2Z is equal to 150 Newton. So now how to determine the alpha, beta and gamma. So you can use that unit vector. So here, so this is the components of the F2, and you must remember that the question given F2 is 800. The magnitude of F2 is 800. So this is the component of vector for the F2. So you can equate that by using the unit vector. So you can have that cos alpha I plus cos beta j plus cos gamma k. So you can have the alpha, beta and gamma. So you can substitute the F2x divided by its magnitude, F2y divided by its magnitude, and F2z divided by its magnitude. So this is the answer for the alpha, beta and gamma. You got it? Alright. So that's all for this lecture. Hope you can achieve the outcome of the lecture, which is we already identify the Cartesian vector, and then you should be able to solve the problem to determine the force resultant and coordinate direction angle for the 2D and 3D. Okay, so you can try to do the tutorial part 2. So that's all for today. See you for the next lecture. Bye.